It is time to cut the music and go live. And with me today is Daniel Roth,
Hi, everyone.
Principal Program Manager at Microsoft, currently focused on Blazor and other wonderful ASP.NET things. Thanks for joining me, Daniel.
Oh, it's a pleasure to be here. Thanks for having me, Ed.
So we have quite the Twitch audience today.
Nice.
It's great to have you with us. So Daniel's going to talk to us today about Blazor beyond the web. We're going to talk about progressive web apps and all sorts of other great stuff. So I'm not going to delay things any longer, Daniel. I'm just going to give you the floor
Oh
and
my.
remind folks that they can ask questions in the chat room. I'll try to interface there and bubble up the good questions to you or answer directly in chat. We also have our Telerik staff with us answering questions and giving away prizes. So I think we have some prizes to give away today. So keep your eye on the chat room, folks, and watch for announcements about those things as well. Oh, and Chris Santi's with us too. He's going to join us tomorrow on our
Yeah.
channel.
Talking about some authentication tomorrow, I think, later this week. That would be great.
Absolutely. So you're welcome to get started, Daniel.
All right, let's do this. Hi, everyone. Welcome. My name's Daniel Roth. I'm a program manager on the ASP.NET team. I work on our web UI technologies in .NET, and specifically, I work on Blazor. And like Ed was saying, we're going to try and take Blazor beyond the web today in this stream. Now, I'm guessing a few of you have wanted to build a web app in the past, and modern web apps have quite a bit going on. If you want to build a sophisticated web app, you're going to need all sorts of stuff. You're going to need grids, you're going to need tab views and wizards and dialogues, forms and validation to give you that rich, interactive UI. You probably also need to worry about things like authentication and localization. You need your app to be able to target desktop browsers as well as mobile browsers. Maybe you even want your app to be installable so that it can run offline, have offline execution, and integrate natively with the OS. Now, historically, if you wanted to build such a web application, the only real way to do it was to write the entire application in JavaScript using a JavaScript framework. But fortunately, thanks to open and modern web standards, that's no longer the case. Blazor is a web UI framework for building rich modern web UI using just .NET and C#. With Blazor, you get the productivity of the C# language. You get the great tooling with Visual Studio, a stable and consistent ecosystem to build your modern web UI, as well as a high-performance .NET backend. Blazor is open source, it's cross-platform, and it works in any modern web browser using just open web standards, no plugins or code transpilation required. Now, how does that work? Well, Blazor actually can function in one of two different ways. The first way we call Blazor Server. In a Blazor Server application, your components run on the server using .NET Core, and all of the UI interactions are handled over a real-time WebSocket connection with the browser. All the UI events get sent to the server, your components handle them, they render, and then all the UI updates get sent back to the browser. Blazor Server is great because the download size of the app is very, very small. It's very thin. All of the hard work is being handled on the server, so it works well on low-power devices. And because your code is already on the server and stays on the server, it can really simplify your app architecture. Blazor Server has shipped for a while now. It actually shipped last year, first with .NET Core 3.0, and then again with the .NET Core 3.1 long-term support release, LTS release. Now, the second way that a Blazor app can run is we call Blazor WebAssembly. A Blazor WebAssembly app runs directly in the browser using a WebAssembly-based .NET runtime that you can deploy with your app. You then build your web UI components using C# and .NET, and you download them into the browser and just run them using that runtime. Again, the components run, they handle UI events, they render, and then the DOM gets efficiently updated directly in the browser. Blazor WebAssembly apps are great because they are pure client-side applications. They run purely on the user's device. They don't require any .NET on the server at all, actually. You can deploy them as a pure static site. They also, because they're running fully on the user's device, they can even have support offline execution. No need to have that persistent network connection like you need with a Blazor server application. And the great news is that Blazor WebAssembly is now released. Just a couple weeks ago at the Microsoft Build Conference, we announced that Blazor WebAssembly is now available and ready for production use. This is basically the beginning of full stack web development with .NET. You can get Blazor WebAssembly with the latest .NET Core SDK. It's shipped with version 3.1.300. Make sure that's the version you have if you're looking for it. If you have a slightly older 3.1 SDK, just go ahead and download and install the new one. It also ships with Visual Studio 2019 16.6 and with Visual Studio for Mac 8.6. So if you have either of those, then you've already got Blazor WebAssembly on the machine and you are ready to go. Now, this release of Blazor WebAssembly comes loaded with features. It supports .NET Standard 2.1, so you can reuse your existing .NET libraries, both on the client and on the server. Do code sharing, share your model type, share your validation logic. Your Blazor WebAssembly apps can be hosted by ASP.NET Core in a .NET Core app for that full stack web development experience, or they can run completely standalone and be deployed as a static site. We have built-in support for authentication using ASP.NET Core Identity with Identity Server, which is a great open source project. Or you can use Azure AD B2C, or an OpenID Connect provider of your choice. And I'm guessing we'll hear a lot more about that later this week at Chris Sainty's talk. You can build progressive web apps with Blazor, and we're going to be looking a lot more at that today. You can debug your Blazor WebAssembly apps both directly in the browser using the browser DevTools, and also from Visual Studio or Visual Studio Code. We're working on also support in Visual Studio for Mac. That should be coming later this year. When your Blazor WebAssembly app gets published, we run an IL linker on the published output to remove any unused code to dramatically reduce the size of the application once it's published. We also aggressively pre-compress the published app to reduce its size even further. We have support for configuration built in, as well as globalization and localization support. If you haven't got started with Blazor yet, you should. It's really easy. Just go to blazor.net. Like I said, you just need the .NET Core SDK. Previously, there were extra steps to install the Blazor WebAssembly template. You no longer need to do that because Blazor WebAssembly is in the box with the .NET Core SDK. You can then start developing your Blazor app using Visual Studio, Visual Studio for Mac, or Visual Studio Code with the C# extension. Now, Blazor was always designed initially for building web applications. Blazor Server and Blazor WebAssembly are both just different ways of building web apps using .NET and C#. But in today, what we want to do is actually start to go a little bit beyond that and take our web app that's happily running in a browser and start to give it more of a native app-like feel. So to start off, we're going to take a look at progressive web apps. Now, what is a progressive web app, or PWA? Well, a progressive web app is just a normal web app. It just implements a number of additional open web standards that give it a more native app-like feel. Now, there's a bunch of different aspects to PWAs, but today we're going to look at three specific features of PWAs. First, we'll look at making your web application installable using Blazor. We'll look at supporting offline execution and also supporting push notifications. Okay, so installable, what does that mean? What does that mean to have a installable web application? Well, installable web apps can be installed on various platforms so that they can be launched like a normal native app. For example, on a Windows machine, you can launch a PWA that's been set up to be installable from the Windows Start menu. If you're on a phone or a tablet, you can pin typically a PWA to like your home screen so that you can launch it directly from the home screen. Once launched, the web app, they're still web apps, and they're still running in a browser, but they often will be given like a native shell, so they look more like a native app. You lose the the browser Chrome with like the address bar and so forth, and they can have their own icons and their own colors and so on. There's basically three things you need in order to make your web application installable. You're going to need a web manifest, which is just a JSON file with a bunch of metadata about your web application. You need to support HTTPS. Thank goodness, .NET Core and ASP.NET Core support HTTPS right out of the box. And then you also need a service worker with a functional fetch handler for your application. And we'll talk a little bit more in just a second about what that is. And once you've got those three basic steps, your app will be installable. Browsers can then detect that this is an installable app, and they will offer to users to let them install the application, like the user experience you see here from Edge. And there's lots of ways to also customize that experience so that you can have other in-app installation flows, where you can like have an install button or advertise installation from your application. Now, what is a service worker? Well, a service worker is a script that the browser runs in the background separate from your web app. They can serve a number of different functions, but one of them is a service worker can act kind of like as a network proxy, allowing you to control how requests are handled for your application. Now, to use a service worker, again, you need to support HTTPS with your application, and they are registered with your application as a script on page load. Now, when the service worker starts running, this is what they do. They go through a life cycle. Well, the first step is the installation step. If a service worker is registered, when the app loads, it's an install event is raised so that the service worker has an opportunity to fetch the assets for the app and install them, meaning to cache them locally on the user's machine. They then go into an activated state, so that app, the installed app, now becomes the actively running application. Now, typically this is happening in the background. So you load your app, the install event occurs, the assets get downloaded onto the machine, and then that's all happening while the user's already using the app. And so often activation is going to happen for real later, like after the browser's been completely closed and then restarted. Once the service worker has been activated, activation is also a good step, by the way, for where the service worker can look for pre-cached or pre-installed, if you can think of it that way, versions of the app and clean those up. Once it's activated, the service worker then goes into its normal flow of responsibilities of dealing with fetch requests, with dealing with messages from the application, and then the service worker may be terminated when it's no longer being used or due to memory pressure and other browser-related concerns.
Now, Daniel, we've got some questions coming in the chat about how do you update your app, and does pre-rendering still work with a PWA? So I don't know if those are in your next few slides, but if you can try to address those questions, I think the chat room would appreciate it.
Yeah, so well, that's actually a great question, because I was just about to talk about updates. So the service, if the browser detects that anything has changed with the service worker script, like when it fetches a new one and there's even like a byte difference from the previous script, then that service worker then goes through a similar flow, gets a chance to install. So it gets notified to install itself, so it can fetch all the new assets for the application. And of course, you want to do that as sort of an atomic unit. Like, you don't want to have the app like partially installed, so you have a weird mix of assets. So the install step will kick off in the background while the app is still running with the previous installed instance. And if everything downloads successfully and it succeeds, only then will it then have the opportunity to go into the activated state. Now, it can't enter the activated state while the app is currently running. Like, you already have the app executing typically, so you have to like actually close all of the tabs with the running application and then reopen. And then the new service worker will then have its activate event called, so that it has a chance to activate. Then it can go ahead and clear up all the old cache instances. So that can kind of trip people up a little bit. Some people, you might expect that you can deploy a new version of the application with a new service worker, and then you just need to refresh the browser and you're good to go, right? Well, not quite. Refreshing the browser will pull down the new service worker. It will install, but it can't actually activate until you close everything down and reopen it again. So there's one sort of period of the browser lifespan where the old app will still continue to run before the new one actually kicks in. And that can catch some people by surprise. It also means that you have to worry about your app running potentially with multiple different client versions kicking around. That's kind of the nature of this game. As for pre-rendering, I don't know off the top of my head of any reason why it wouldn't work. But I'd have to go check into that. Pre-rendering with Blazor WebAssembly in particular, which is really what we're talking about here, has its own set of complications because you now need to make sure your components can run both on the server and on the client. I have to look into that one. I'm not actually sure off the top of my head.
Thanks.
All right. So that's sort of your basic intro to just getting your app installable. Let's go take a look at how can we create an installable Blazor PWA. All right, so like I said, to get started with Blazor, you're just going to want to go to blazor.net, and that will take you here to the Blazor homepage. Just click on Get Started, follow the docs to get your machine set up. You just need the new SDK, or if you have the latest version of Visual Studio or VS for Mac, you're already set, you're good to go. I'm going to go ahead and pop up Visual Studio, which I've already installed. I'm going to create a new app. And we're going to select Blazor app. If you can't find it, you can just search for it. So search for Blazor. And there's at the top. We'll click Next. All right, and let's create our first Blazor PWA. Sounds like a good name. OK, and here are those two options that we talked about before. There's Blazor Server, which is the server-hosted version of Blazor, and Blazor WebAssembly. I'm going to pick the Blazor WebAssembly version because I want to build a PWA. And then we have a few other options over here on the right-hand side. Let's take a look at these. So down here we have, first of all, the option to make this app ASP.NET Core hosted. If we do that, then we will pair our Blazor WebAssembly app with an ASP.NET Core server. That's that full stack offering. If you leave this box unchecked, then basically what you have now is a static site that you can deploy to a static site hosting solution like GitHub Pages or Azure Static Site Hosting. This other option below is the option to create a PWA. This will add some additional assets to our application so that it supports PWA scenarios. So we're going to want to select both of those. Up above, if you want, you can also go into the authentication settings and enable authentication for your application. We're going to leave that for Chris to take care of tomorrow. All right, so let's go ahead and create this app. So now Visual Studio is going to set up our solution for us. Remember, I selected the ASP.NET Core hosted option. So we're actually going to end up with a multi-project solution. The client project, which is what we see up top in the Solutions Explorer, that's our actual Blazor WebAssembly app. And then the server project is the backend ASP.NET Core server that's hosting our Blazor WebAssembly app. The client project builds. The static files from that client project are then just hosted as normal static assets from the server project. OK, let's go ahead and just run this. We'll let Visual Studio build and start up the server and host it. And hopefully, and just given a second, we should see a simple single-page app with our classic Blazor purple gradient. Let's see if there's any questions while we're waiting. Any documentation for deploying Blazor in SharePoint? We don't have any documentation on that. But I know there are some open source projects out there for like integrating Blazor into SharePoint. I think it's like Blazor Point or something like that is the name of the project. If you're looking for community projects, by the way, like stuff done by the community around Blazor, I would point you to aka.ms/awesome_Blazor, okay? aka.ms/awesome_Blazor. And that will bring you to a GitHub repo that's maintained by the community, which has all sorts of cool stuff about Blazor, component libraries, interop libraries, samples, and I don't know, I don't know if Blazor Point is on here. Let me see. Yeah, Blazor Point is you might want to check out for using Blazor with SharePoint. OK, here we've got our app. And you can see we've got some tabs. We can click around. We got the button that has a counter. We've got a fetch data page, which is pulling down some weather forecast data and rendering a simple little table. Pretty simple. I'm sure many of you have probably seen this app demoed about 100 times. OK, but the interesting thing about this app is that you'll notice that up at the top, there's this little plus button that says Install Blazor. This means that Edge is detecting that this app is a PWA and that it is installable. If I click that, we then pop out of the browser, and now we can see our web application in a native shell. It's got a nice native shell. We've lost the browser Chrome. It still works. It's the same app, same functionality, no different. This is still also running as a web application. Like it is basically a browser here. It's been made to look like a native app. If we go to the Start menu, we can also see that our Blazer PWA is now showing up in the Start menu. And we can launch it from there, and that would launch us there. I just launched another instance, so now we have two of them. So you're getting that installable experience for this web application. Now, how did we set that up? Let's go look at the project. In the client project, we basically gave you two things. We gave you this manifest.json file. You see that there? That's the web manifest for this application. And then below it, we also gave you a service worker. And I know some people kind of freak out when they see that JavaScript extension. There are some cases in Blazor, I will admit, where you do need to occasionally deal with JavaScript. With service workers, it's mostly a recipe-based approach. You kind of implement the recipe and you're done. So hopefully, for the most part, we've written this JavaScript for you. But yeah, sometimes you do need to deal with a little bit of JavaScript in Blazor. We're working as much as we can to minimize that. So here's the manifest, and it just has some metadata about the app, like its name, how it should be displayed, like should it be full screen, should it be in its own Chrome, what its background color is, and some icons so that when you install it, you can customize how the icon shows up either on when you're pinning it to the home screen or in the Windows Start menu. So we give you a little manifest, and you can, of course, add this. This is not a Blazor specific concept. This is just an open web standard. Now, the service worker, if we open that, it looks pretty bare bones. It's just got a very simple line of code here for dealing with fetch. This is for development purposes. It's not doing anything with like caching files or offline. It's basically just acting as a pass-through proxy right now during development. And that's so that you don't have to deal with caching issues while you're trying to make updates to your app. There's another version of the service worker in this app that if we poke a little bit, we can see it. There's the published version. A lot more going on in that one. Whew, we'll come back to that in just a sec. Now, these files are both registered in the index.html file. So up at the top, we can see there's the manifest. So there's a link to the manifest file with the correct relationship. And then down below, there's just a little bit of script that's registering that service worker for this application so that it can then receive the corresponding events. And that's it. And that sets up your app as an installable PWA right out of the box.
So there's still a couple questions coming in around caching and updates and things. So in the example you just showed, there's actually a service worker that helps with cache busting. So the development cycle is fast and you don't have to worry about assets being cached where you might have made a change. But there was a question around like controlling installation and what if there's a major update to the app. If there's a major update, the service worker should pick that up when you restart the app. Is that correct?
Yeah, well, the browser will pick up that there's a new service worker when you reload the application. So to check to see, well, is the service worker the same as it was before? Yes, no. If it's not the same, then the service worker gets a chance to install, to activate. And it's in that installation logic where the service worker will pull in all of the new assets for the app. Like if you did a major update, it'll pull in a completely new set of files, cache them in a separate spot, and then say, yeah, okay, I succeeded, I successfully installed. That all happens in the background while the old service worker's version of the app is still running. And then at that point, it's waiting to activate. And then when you've closed the app down, that service worker then gets an opportunity to activate when the app loads again. On activation, it then switches to the new cache, and all the old cache instances typically get cleaned up. We'll actually look at that in just a second. So we'll see some of that code that's in the more the published version of the service worker implementation.
Excellent. And there's another question I thought was interesting. It says, Mr. Smoofy asks, is it possible to control if there is only one instance ever running? So I'm thinking the question is probably around can we launch multiple instances of the app on our desktop? And my gut reaction is that the app has no idea if other instances are running of the same application.
Yeah, not that I'm aware. I mean, you saw that obviously you can launch 2 instances because I had 2 instances up. Whether you can like control for only one, that I don't know. I don't know if there's a way to do that.
Yeah, my guess is it's similar to opening 2 browser tabs. They're in a sandbox. They don't really know about each other, and I don't believe wrapping them in a PWA gives them any special ability to do anything different.
No. Again, I just want to also iterate that while we're showing how to do PWAs with Blazor, like the PWA set of technologies like service workers and manifests, they're actually just open web standards. So they're agnostic to Blazor, or if you're using a JavaScript framework. So a lot of this stuff is just the way the functionality that browsers provide. So let's talk now about the second feature, which is offline execution, which I think a lot of these questions are related to. Service workers can cache the app assets for offline use, and you typically need to pick what strategy you want to use for that. There's a number of different strategies. Like you could try to detect if the app is online or not, and use the cached versions if you're not, and use go online if you are. That tends to be a little unreliable because the check for detecting if you're really online can be a little flaky. Like maybe you're online, but the network is just really terrible, that type of situation. So the caching strategy that we give you out of the box in Blazor is a cache first strategy. If we have a cached version of the files, then we'll use those. If not, then we will go online. And of course, there's always that update check to see if a new service worker has been installed, so that a new cache can be established. For data you have to handle in the application yourself. So like if you're pulling, like we saw the weather forecast data, there's nothing magic that will just cache the weather forecast data for you. But in your application, you can use things like local storage, IndexedDB, to cache data locally, and then implement whatever synchronization strategy makes sense for your app. Now, as you can kind of tell from the questions, implementing support for offline in a web app is non-trivial. Like there's some interesting considerations that you need to think about. We do have a fairly extensive doc in the Blazor docs for all of the various nuances of dealing with offline, and so I would point you to this link to check out those considerations if you decide to support this feature. But let's go take a look at offline execution. Okay, so let me minimize the browser. So here's our app. This is a PWA. Now, I said that this app supports offline, so let's try it. I'm going to bring up the browser dev tools for this application. Remember, it is really a little browser that's hiding in this native Chrome. And then let's go to the network, and we're going to turn off the network. So now this app has no access to the network anymore. And let's trigger a refresh. And will this thing work? Well, no, it doesn't work. And that's because, like we saw before, during development, the app is using this sort of minimalistic service worker. It's not actually even doing any caching. For the published application, though, here's where all the actual logic lives for dealing with installing the app. And we can take a look at this real quick. So here's the onInstall event for the service worker. And this is using a assets manifest that we create when the app is built to figure out what are all the assets that make up this Blazor app that need to be cached. You don't see it in the Solution Explorer because it's produced on build, but if we go poking around, we can find it. Where is it? It's like I think, yeah, so this service worker assets.js, here's a list that we generate with hashes for every single asset that makes up the application. So that assets file gets loaded by this service worker, so it knows all the things that it needs to cache. It does some filtering to make sure it's not caching stuff that really shouldn't be cached, or things that you do want to make sure in addition that get cached, and then creates the cache with a unique cache name and caches all those files. All right, so that's the onInstall event. And then on activate, this is where it goes through and deletes all of the unused caches if this app was installed previously. So you close down the browser, the new service worker is ready to kick into gear, cleans up its after all its buddies that had run before, and sets up the new cache. And then on fetch, this is the part that's intercepting each of those network requests and deciding to instead handle them using the cached files. So it's looking, for example, for whether there was actual full navigation or not. This is a little trick here that's important. Like I said, there's nuances to offline, so make sure you check out the docs. The doc is also linked up here at the top. But what this is doing is, well, when you're caching a request to, like, say, /counter, well, /counter actually uses client-side routing to route to the counter component. So really what you want is to render index.html, like the root page, and let that client-side router handle that routed request. So when you're doing the caching logic, you need to take that into account for navigating requests. So that's what this logic is doing. Otherwise, for like other static assets, like the DLLs, the WebAssembly runtime or whatever, those can just be served from the cache. If it's in the cache, it uses it. Otherwise, it makes a network request to pull down the new files. OK, so we want to use this version of our service worker. How can we do that? Well, we need to publish the app. So let's go ahead and right-click on our server project, and we will select that. We're just going to publish this to the file system. It looks good. And we'll go ahead and click publish. We're publishing the server application, so we're going to publish the back end, which will then have inside of it all of the static assets that make up the Blazor WebAssembly app. Then we can just run the back end. It will host the files for us, and we can try out the offline support. All right. So while that's going, I'm going to go ahead.
Apologize if I missed this, Dan. While that's publishing, the service worker.js and the service worker.publish.js, does the publish task switch that service worker out? How does the .published
great question. Yeah, we have a little bit of MS Build magic. Like you can see in the project file, like there's this service worker item group that's saying, like, this is the service worker to include during development, but when you're publishing, please use this one. Then we have some MS Build logic that takes care of swapping when you actually run the publish. Yep, it's exactly the same.
Does that work with other types of publishing tasks, or just the one within Visual Studio?
The publishing tasks are all run even when you do like a .NET publish from the command line. So it's not Visual Studio specific.
Okay.
Okay, so we've got the app published. Now we just got to go open up a command prompt, and let's go find it. I think it sits in the bin release publish. Okay, so it's somewhere in here. And what's the name of the app? It's Blazer app PWA server.exe, I think is what we want. Let's go ahead and get that up and running. Windows is checking to make sure this file is safe. Oh no, what did I do wrong? What did I do wrong? Unable to start cache. I probably have another. Oh yeah, I've already using this. So what's happening here is the port 5000. I have another app that's already using that port. So I'm just going to do a quick little trick, which is I'm going to set an environment variable that's going to change the port for the application. And I think I even have this in my demo steps. Yes, this is what I want. We'll switch it to SIP port 6000. There. And by just doing that, we should be now good to go. There we go. OK, so now our app is running. And let's pop up a new browser instance. and browse to $6,001, I think is what I need now. Okay, it's a new port, so it kind of looks like a new app. We're gonna have to reinstall it, which is fine. All right, so there's the app. And now this one, hopefully, should work offline. So let's bring up those browser dev tools. And we will set the from online to offline. And let's go ahead and do another refresh. Boop. Okay, so that was like, like loading the app anew, and it just magically worked, right? Like we have the app functioning without any network connection. So this is now an offline functioning app. Now, not everything works offline. Like if we go to the fetch data page, it's going to try and make a network request to a backend API, and it can't because it doesn't have the network. So data is something we still need to handle on our own. Now, to show a little bit of that, I actually have a different app, which I'm going to switch to. Let me close this one down. This is an app that we showed at the Build conference. Let me make sure my backend server is still running for it. It is. This app is called Car Checker. Here it is. And this app is supposed to be like an app that you would use if you were running a rental car company and you have an attendant who's supposed to handle cars being returned. It's like when you drive your car up into the parking lot and they check out the car, see if there's any dings or scratches that you added to the car's look, and take notes about that, and then record the gas and the mileage and all those types of things. So it's a nice little app. Again, it's a PWA, all implemented in Blazor using Blazor WebAssembly. We can search for a car. We get like nice autocomplete features. Like that's another one of those features that you normally would have to write with JavaScript, but here that was all implemented with .NET and C#. We can select a car. We've got this cool sort of 3D visualization of the car. We can see all the parts of the car that had notes taken about them before. Looks like this car has had a rough go, like not an easy life, not been treated gently. You can like update the mileage. Let's say it has now 45,000 miles. If you put in something ridiculous, it has forms and validation. This is all implemented with Blazor WebAssembly. We can change the amount of gas and so forth. Now, this little 3D visualization, you might wonder how that is implemented. That's done with 3JS, which is a popular JavaScript 3D rendering library. Blazor supports JavaScript interop, so you can call into existing JavaScript libraries if you want. So this shows that if you have libraries that you want to reuse or libraries from the ecosystem, you can still use them. You're not shut off from the existing ecosystem.
Some questions coming in, Dan. Is the Car Checker app available on GitHub?
Yes, it is. So that is available at... I have the links also.
Chat room's already got it. Marin from our support team.
There you go. Thank you.
Right on top of things.
Yeah, it's on Steve Sanderson's GitHub repo.
Also, is there any performance difference between a published Blazor app, whether it's PWA or not, published Blazor app versus when you're in development mode?
Not significant, I don't think. Like in terms of the actual runtime execution of the app, there is significant difference in terms of the load size of a Blazor WebAssembly app. So when you're developing your Blazor WebAssembly app, we want the development workflow to be as fast and iterative as possible. So we don't run like the .NET linker and pre-compression on the built assets while you're in development. So if you look at like the network trace for a Blazor WebAssembly app during development, if you can find where the asset, we cache the assets after first load. But if you find it, you'll notice like, oh, like it's actually a little bit big, 5-6 megabytes for a default app. And that's just because they haven't been pre-compressed, haven't been linked. When you then publish the app, the IL linker gets run, all the unused code gets removed. We broadly compress the app at the highest setting to really shrink it down, and it shrinks down to like 1.8, 1.7 megabytes, I think, depending on how much you decide to strip out. So load time performance definitely is different during development. But of course, during development, it's usually right there on your machine anyway, so not that big a deal. But for runtime performance, I don't know of any other significant difference.
Excellent.
Okay, so you can add notes to this car to say, there's something else wrong. Let's say the user returned it and there's something wrong with this wheel. So let's add a note. what should we put here? Like might need to be replaced, something like that. And then you can add a photo. Where did I put my photo? Yeah, so this is the car wheel. Yeah, it looks like that might need some work. And we'll save that. And so now we have a new note that shows up with the rest of the notes. Okay, and we can save that data. And so now that car has been updated. And if we go back to it, oops, that was the wrong one. You can see that my note on that wheel has been saved, and that all works beautifully while this app is online. If I switch it now to be offline, let me F12 and move to offline. Let's try refreshing the app just to see if the app functions. Yep, works just fine. It's pulling. You can see the service worker is kicking in a bunch of cases to preserve the cached assets, but also the data is available as well. Like we have like our wheel is all there. Like we were able to pull in we can search for cars. That's because we've cached all the car data locally in this app using IndexedDB. That's how that's working. And if you try to make a change, let's I don't know, let's put something else in here like badly scratched, save. And if we try to save again, you notice at the bottom, the app detects that it couldn't sync to the server, like the request to the server failed, but it's storing locally the edits that it made so that the next time when the tenant is back in with network coverage, right now they're out in the parking lot where they have terrible network coverage, but they go back to the office and the network comes back online. Let's turn the network back online. They can then retry the request, and retry the request. What did I do wrong here? Why am I failing? Is my server down? No, my server is up. Put it back to online. Well, I'm not sure what I'm doing wrong there. Looks like it's online. Let me refresh again. Syncs. Oh, I wonder if the issue here is actually that my credential has expired. Like there's a little, I think there's a little issue with this app where it doesn't, the token expires and it does not refreshing correctly. Let me see if I can log back in. So this app has full authentication, which is kind of nice to see. Stealing a little bit of Chris's thunder here.
Missing a period there.
Yep, thank you.
There's a question in the chat room about can you show the user that they're offline, and we saw the message come up and they kind of caught that, but is there a built-in API for checking to see if somebody's offline? Is there like an event that we can hook into in Blazor, or is that some JavaScript interrupt that we need?
There is an API that you can use. It is a JavaScript API. Blazor doesn't provide any out-of-the-box wrapper for it. In fact, most of the stuff that you do in the service worker logic, well, we don't try to do a C# wrapper over those things. You could imagine separately loading the .NET WebAssembly runtime in a service worker and then writing your service worker code with C#. But typically the service workers are not like huge chunks of JavaScript. They're fairly contained, so we haven't bothered doing that. So yeah, you would just, in your service worker code, call the corresponding JavaScript API for checking whether you're online or not. All right, I'm going to try this one more time because I think it was just an issue with my network my sign-in credential. So I add another note. I'm offline right now. Broken. Save. Okay, save again. Could not sync. Now we go online. Should be good. Let's retry, and there we go. Okay, yeah, so it's just a problem with my my login credential. So yeah, so that is now an app that is both supports offline execution and also supports offline handling of data locally in the app. Just to show you the code real quick, because I know we're getting short on time. Let me go to, where's Carter?
It looks like Steve Sanderson's joined us in the chat room as well. So
nice. Hi, Steve.
Nice to have you, Steve.
That's great. Let me pull up car checker. Here's the code for the car checker application. This is what you can find on the on Steve's site. Thank you, Steve, for implementing this app for us. Let's give this a second to load.
John Galloway's here as well. Nice to have the .NET folks joining us.
Okay, so if we look in car checker, and we see that sort of standard solution structure, right? We have a server project, which is the ASP.NET Core host, and we have the client project with the application. If we go looking in here, we can see that on save, let's see in the vehicle editor, this is the page for when you're like adding edits to the vehicle. This has got a form, and when the form is submitted with a valid submission where the data has been validated, then we will call this save method, which is down below. So in the save method, it uses the this vehicle store API in order to save the vehicle data, and that's actually going to store it locally in the using IndexedDB. Let's go find that data type. So local vehicle store, here it is, and next save. So it's going to do just a quick update doing this put async call, which eventually is going to bottom out at doing a little bit of JavaScript interop again. I know we said promised you no JavaScript interop, but there is a little JavaScript interop in this app to deal with IndexedDB. Hopefully at some point we'll have a nice JavaScript interop library from the community for doing that. But Steve in this app rolled his little own implementation. So in this IDB.js file, not that one, the load vehicle store file, this is the code that the C# code is then calling into to handle all the interactions with IndexedDB. And you can tell it's not too bad. It's got a little bit of JavaScript for setting up the schema of the database, and it's got like get all, put, delete type of operations on the database store. Now that little synchronize widget that we saw at the bottom of the application, that's implemented by this component. When this component loads, it tries to do a synchronization with the server, and it calls again into that local vehicle store service in order to synchronize the data. All the edits that have been saved locally in IndexedDB, try to push them up to the server. If that succeeds, like if it doesn't throw an exception, then you're good to go. If it fails, then it saves that the last sync failed and puts up a little bit of UI up above to say, could not sync the last edits, and then gives you a retry button that you can use to retry the request. So that's the type of logic you would do to handle offline data. All right, let's talk about push notifications. All right, so the last feature I wanted to talk about with PWAs, we have about 10 minutes. Okay, move a little quicker. Push notifications are a way for web applications to notify the user even when the app isn't running. It's like an offline notification. And this is useful if you have like important events that you want to let the user know about for your application. The push notifications are kind of interesting the way they work in browsers. They actually involve like a hosted push service for sending the notification back to the browser. The flow kind of looks like this. In the browser, you need to first subscribe the user to the notification, which involves asking for their permission. So you can't just spam them with notifications without them saying it's okay. You have to ask them. And if they give the permission, then you can get a subscription for that user. The subscription is just a bunch of tokens that signify like, yep, this user has said it's okay to send them these particular notifications. You then send those that subscription to your app's backend to usually to persist, like you would put them in your database, and then to handle. And when you want to now send a notification to the user, you use the push service for that particular browser. Now each browser has their own, and the exact endpoint that you're supposed to use depends on the browser. That information is provided as part of the subscription. But the interface for the push service is standardized. And so how you send that API request, that push request, is done in a standardized way. The push service then handles sending the push event back to the browser, to the user, and they get a notification on their machine. So to set up push notifications, you basically need three things. You need to subscribe the user to the notifications with their permission. You trigger the push notification, then from your backend, based on whatever event is important, like the pizza's now been delivered, and you want to let the user know. And then you handle on your backend sending the push request to the push service, which will then notify the browser. And in your service worker, you have to handle that push event to then show the notification to the user. All right, I'm going to show this really quick. So I have this pizza store app. If you haven't seen this app before, it's really fun. It's actually part of a workshop that we provide online. You can go to aka.ms Blazor workshop. And this is the Blazing Pizza store. In this workshop, you build this entire pizza store over the course of like 9 or 10 labs. It's a self-paced workshop. Yeah, so if you haven't gone through this, I highly recommend it. It's a great way to learn Blazor. So I have the app here on my machine. Let's go ahead and start it up. There we go. I'm just going to load up the server. This app's kind of funny because it's all British pizza in honor of, I think we first showed this in London, and also it's kind of in honor of Steve Sanderson, since he's also from the UK. Hello everyone from the UK. Okay, so here's the pizza store app. Let me just make sure that I haven't already granted permission for notifications. Looks like we haven't. Let me go ahead and order some pizza. This is also a P. Okay. So let's go ahead and let's order the Brit, and then what do we want to do here? Let's get some pizza with duck sausage, and maybe served on a silver platter, because why not? And some fresh tomatoes. Okay, great. Go big or go home, right? It's expensive pizza. All right, so that looks good. Let me make this big again. And let's go ahead and order that. And I'm not logged in, so let's go ahead and log in. Okay, now you notice I'm about to check out for this pizza, and the app is asking me, hey, the app wants to show you notifications. Are you okay with that? So this is the first part of that push notification flow kicking into gear, where we are requesting a subscription for the notification. So I'm going to allow that. All right, and then let me go ahead and put in just some dummy data here for the where to deliver it to, and now we'll place the order. All right, we got a little status page that's showing where I am. It's not actually where I am, but some random place I think in London. And it takes a minute for so there's our notification. Everyone see that down at the bottom? There's the pizza has been dispatched, so the driver is now on his way, plowing through the streets of London. I guess that's he must be on like a helicopter, or maybe it's drone delivering our pizza. And then once the driver actually arrives, we'll see another notification to say that the pizza has been delivered. Okay.
I believe that location is the location of the first Blazor workshop.
That may very well be the case. I don't remember. Has it been that long? Okay. So how does that all being set up? So let's go to the checkout component. That's the component where I had ordered my pizza and I first saw that notification. So in here, you can see that when the checkout component initializes, it requests a notification subscription using some C# code. And again, I know I apologize. There, our pizza just got delivered. Everyone see that? And I can even click on this, and the app is set up as a PWA as well, and it opens up the PWA locally on my machine, so we can full push notifications. That's cool. Okay, so that's the app. We have a little bit of JavaScript here that's setting up, making the standard JavaScript calls to request the notification subscription. And we could go look a little bit of that JavaScript code, but it's nothing too fancy. Like this is the one call right here to request the subscription. And it involves setting up like these keys. There's a little bit of some hoops that you have to do in order to set up that subscription. But there's a little bit of code there that you can check out in the workshop. And then it makes a call to the back end of this app using this orders client to pass that subscription to the server so that it can be stored. If we go look at the server project, we can find that in this notifications controller. So here's that API endpoint. We're calling this subscribe endpoint, and this is just saving the subscription into the database. And this has like those tokens and the actual push service URL that we need to use for sending the notification to the user. Okay, once an order has been made, which if we go back to the application, let's see, was it checkout was where we were at. So once we've placed an order, it sends the order, it places the order to the server using the orders client again, and that will make a call to this orders controller and call place order, which is down here. And in this method, down at the bottom, we can see that it's getting the notification subscription back out of the database, and then creating a little task that will send those 2 push notifications back down to the client. And here's those 2 push notifications: the one for the order being dispatched and the one for the order actually arriving. This is all being handled on the server. How are those notification requests being made? Well, here's the code, and don't do this. Like, don't put your keys in code. This is just for workshop, learning purposes. But actually sending those push requests to the push service is a little bit involved. Like, there's some crypto stuff that you got to do. Fortunately, this is .NET, has a great ecosystem, and there's a third-party library that you can use to send these push requests. The library that we picked for this app, what is it? It's called, actually, let me bring up the NuGet Package Explorer. Yeah, this web push library is the one that we use for sending those requests, and you can go check them out on GitHub. Here's the URL for their library. Give them a star because they did a great job. So we just use an existing .NET library for sending those requests. But once those requests... Dan,
is the request actually coming out of ASP.NET Core, or is it using like a third party, like a SendGrid or something like that?
So you can see right here, like, it's using this web push client, and it's sending it to using the push subscription to send it to the push service. So it's going out from ASP.NET Core to some other endpoint. And that's browser specific. Does that make sense? Mm-hmm. Okay, great. So it tells the push service, I want to now send a notification that this user gave me permission for. Here's my subscription. And then the push service will then send the push notification to the browser. And we have to handle that client side in our service worker. So if we go look at the client app and go poke around in the service worker code, you can see it also is registering a push event listener to handle actually showing the notification. So that's where the notification actually shows up. All right. I know I'm at time, but I'm gonna keep on going because there's one more thing I want to show you. Like, we have been talking about going beyond the browser. We started with building web apps with Blazor Server and Blazor WebAssembly. We then started making those apps have a more native-like feel by building a PWA that supported being installed, offline execution, push notifications. But we've been talking for a while in Blazor. Even early on in the project, we knew we wanted Blazor to be about more than just web apps, and it was designed with that in mind. And we've been experimenting with taking Blazor from the web to actually supporting native like desktop and mobile applications. For example, you can imagine taking your web UI components that you've implemented in Blazor and putting them in a native app, like a native mobile app or a desktop app, and reusing those UI assets. That's sort of a hybrid approach of a native app with hybrid web UI. We call that Blazor hybrid. And you can even go further. Like, Blazor's component model is very flexible. It's actually not coupled to how the pixels get drawn on the screen, how they get rendered. Typically with Blazor, you're rendering HTML and using CSS, but the component model actually doesn't require that. You can replace the renderer with something else that renders to whatever you'd like. Like, if you want to render to native UI controls of the machine, you can do that using Blazor's component model. And we call that Blazor native, where you're not only implementing a full native Blazor app, but actually implementing even native UI, not even using web tech for the UI. And that's kind of nice because it means you get that native look and feel, but you still get the familiarity of the Blazor programming model if you're coming from that background, like you're a web developer and that's what you know, and you want to use .NET, then you can use those skills to build a full native application. Now, we've done various experiments for Blazor Hybrid, Blazor Native. Like we did an experiment early on where we tried building Electron apps with Blazor. Electron's basically like an embedded Chromium browser shell with some code, so you can build cross-platform desktop apps. Usually you do them in JavaScript. With Blazor, you could do them with .NET. More recently, we've also released this experimental project called the Mobile Blazor Bindings, which enables you to build fully native UI. With the mobile Blazor bindings, you're running natively on the machine. You're writing Blazor components. You're writing Razor files, but you're actually rendering to native UI controls. You have full access to the device and its capabilities, full access to the .NET ecosystem, but using a familiar web programming model to build your app. And this is something available that's for you to try out right now. And I just want to show it to you real fast to give you a taste of how we hope to take Blazor even further beyond the browser for supporting even full native desktop app development. Okay, I have another solution right here. So this is a simple little app. This is a mobile Blazor binding app. In this case, now mobile Blazor bindings is a collaboration between us and the Xamarin team. So the underlying technology here is Xamarin Forms. And here's the main component for my little application. I'll go ahead and run this so you can just see what it does. Here we're using the WPF bindings for Xamarin Forms. So we're using abstract controls that are being mapped to WPF so we get a native desktop app, but using the WPF rendering system. And we get a counter, like we always do with Blazor, of course, right? We've got a counter. But this is a fully native app, and the UI controls here are native controls. Like we're using WPF controls in this case for running the app. You could also take this same code and compile it to run as like a Cocoa app on Mac or as a mobile app on Android or iOS using the same tech that Xamarin Forms uses. But you can see we got to write this app with Razor. Like this is Razor syntax. These tags, we're no longer looking at HTML. These are components that wrap the underlying native controls. Like we have a content view and a stack layout, but it's all Razor syntax. So let me close down the app previously and let's add some more Razor in here. Like see if we can write a for loop. And I equals 0, I is less than 3, I plus plus. I think I did that right. And what do we want to put in here? Let's put in another label component where the text is set to something that we're going to use C# for. Let's put let's just put the count. Let's just put whatever that count is. And let's make the font bigger. Font size, what do we have above 40? Okay, so this should generate 3 labels using normal Razor logic. Let's rerun this app. Oh, I forgot. I gotta toString this because it's going to be a string, not an integer. Text is a string, of course, and we rerun the app, and now we have 0, 1, 2. So we just created a bunch of labels using Razor syntax. And so this is all native UI, and this is what the mobile Blazor bindings offers today. Still can click on the count. But what about hybrid? Like, what if you have some web UI that you want to use in this native app? Like, ideally, you could just like start typing some HTML here, like H2, hi, I'm web UI, right? You can't do that because this is not this is based on these native controls, not on HTML. But what if you had another control that's a Blazor web view? So it's a web view that allows you to render some web UI within your native application. What else could we put in here? Like I'm gonna put a p tag. This is so cool, right? Perfect. Okay, so we got some simple HTML. Let's run it again. So hopefully what this web view is just a control that wraps the browser control from Xamarin Forms. And now we're rendering some web UI inside of our native desktop application. Still click the count. All right, but it's not just a web view, like it's a Blazor web view, right? So we should be able to put some C# logic in here. So let's do this. Let's say that for the header, the current count is, and we'll just render the same value that we have above. And then let's turn this into a button with a lowercase b. And let's say this will be count. And then let's use the same on-click handler that we used in the native part of the UI, but now we're going to do it with web UI. And we have to use the web version of this because we had to register a web event. I think that looks right. And let's rerun the app. Now it's tied to the same state. In both the native UI, notice it's using this counter state.current count. And in the web UI part, it's using that same state. So when I click the count above, it updates the counter in both the native UI part of the app and in the Blazor WebView part of the app. And both count buttons work exactly the same. So we can do Blazor stuff inside of this Blazor WebView. And in fact, in this app, we have the entire default Blazor application tucked away in here, and it's referenced by this app. Let me just grab the little snippet for setting that up. Yeah, this is what we want. Okay, so instead of this Blazor WebView, I'm going to put in this one. And here what we're doing is we're rendering the root app component for the default Blazor template entirely within a native application. So let's try running that.
Little Blazor inception, huh?
Yes. Yes. Let's Blazor all the way down. All right, cool. So now we've got like the entire default Blazor app running inside of our WPF application, and the counter is wired up to the same state, so I can click on the counter and it works the same way as we saw before. So this is kind of cool. This means that if I have like existing web UI that I want to reuse from my cross-platform native application, I can do that. And so as the last demo I wanted to show is we actually have the entire car checker application here. And let me set this as the start project that is now hosted inside of a mobile Blazor bindings-based application. And let me go ahead and run that.
Now, since this application is running on the desktop, we're getting the full .NET framework, not the mono.wasm version.
Exactly. Correct? So there's no WebAssembly in this app. Like this is a native app, and it's running using a .NET runtime that's native to the machine. It's not using a WebAssembly runtime tucked in a browser. And then we're just talking to the browser controlled in order to render the pixels. So this is the same set of components, but it's now running with, you get all the performance of the native platform. You also get its capabilities. So let's just show that the app still works. Like we can like search for a car and do JavaScript interop. We got our 3D thing. But we can do more of that stuff that we couldn't do from a browser. Like down here below, Steve was kind enough to add a open report button. Let me actually get a car that has some issues. I think this one, yeah, this one's got some issues on the bottom. Okay, so we've got some notes for this car, and there's a button here for generating like exporting the data for this particular car. And if we click on that, we just opened Notepad from our application. That's not something you can do from a browser app, but because this is a native application using native.NET runtime, we have access to those capabilities of the device. So this is something that we're working on. The mobile, the Blazor WebView is not currently public, but it's something we're working on with the Xamarin folks to make part of the mobile Blazor bindings, and we hope we'll have something there to share soon.
Yeah, this will be really interesting for us when it's published to see how if we put a Telerik UI for Blazor data grid inside of Xamarin Shell and how to interact with OS and all those type of things. It'd be an interesting scenario. Yep.
So that's what I had to show today. In summary, you can now build full stack web apps with Blazor using .NET and C#. Both Blazor Server and Blazor WebAssembly have been released and they're ready for production use. You can build progressive web apps with Blazor WebAssembly that are installable. They can run offline. They can handle push notifications. They can do anything that a modern web app can do. And we also encourage you to try out some of the experiments that we've been doing with native apps using Blazor, especially the experimental mobile Blazor bindings. Here's a link, a list of resource links from the various things that I showed today. Of course, go to the Blazor.net homepage and install the bits. We have lots of docs. You can find the Car Checker app online as well as the Pizza Store app. and there's the link for learning more about the mobile Blazor bindings. And with that, I encourage you to try out Blazor today, and I'm happy to stick around for just a few minutes and answer some questions.
So we had a couple questions come in. One of them was about, I think it's more of a terminology thing. Is Blazor mobile bindings MAUI? How is it related to MAUI? What's the clarification?
Some people may have noticed that MAUI showed up in that demo. If you haven't heard of .NET MAUI, .NET MAUI is our effort to create a cross-platform UI stack for .NET. It's happening, being worked on for the .NET 5, .NET 6 wave. And it is basically taking Xamarin Forms and rebranding it and broadening it to support more scenarios and more programming paradigms. So it's fundamentally based still on the Xamarin Forms tech. With the mobile Blazor bindings, we're taking Xamarin Forms and experimenting with how can we create an experience that's more appealing to web developers. And we expect that those investigations will accrue to MAUI. That in addition to being able to write a MAUI app using XAML or using the new like plain old C# programming model that they're working on, I imagine you could also choose to build your MAUI app using a more web-like programming model, including hybrid scenarios using Blazor. That's something that we're investigating with them, and hopefully we'll have more to share on that in the future.
The next question is about Microsoft Power Apps and how that relates to the development of MAUI and Blazor and these type of things.
Power App supports .NET. That's about my extent of my knowledge, unfortunately. I know you can do a bunch of .NET stuff with Power Apps. I think there was we've had some discussions with them about enabling like a Blazor-based extensibility model for Power Apps that might be interesting to look at, but nothing official, nothing really to share there. Not really aware of any other overlap.
I think my general take on it is, please correct me if I'm wrong, the Microsoft Power Apps is like a low-code environment type of thing where, the MAUI and Blazor, you're building an entire app from scratch. You've got a team of developers, that type of thing. They're kind of two different audiences that, if you picture like a Venn diagram, like they cross over in the middle somewhere, but they're different tools for different developer audiences. Is that about right?
That is true in terms of their core scenarios. Like Power Apps is for like citizen developer type of scenarios. Really easy way to create quick, rapid development of applications. But they do have like an extensibility model, and when you get into the extensibility model, you start to get into more of the professional dev type of scenarios that we typically deal with ASP.NET Core and Blazor. And so you could imagine, maybe Blazor could have a role to play if you wanted to extend your Power App in some way with the help of some professional devs, and you wanted to do that using .NET. But like I said, that's all just like really early thinking and discussions and brainstorming. Don't know if anything will come of that.
I think that was more the answer folks were looking for. Just appreciate that, Dan. I especially want to say thank you for Dan and your team for coming out and helping us with the session today. It looks like everybody's really enjoyed the content. There's a lot of good chatter here at the end about everybody really just enjoying the session in general. So thank you very much. We've got lots of content planned for the rest of the week as well. So we've got Chris Santi joining us tomorrow to talk about authentication. So him and I are going to dive into authentication a little bit and see what we can do there. There's some really cool components that are baked into the framework now that let us, trade out views for different roles and things like that. So we're going to take a look at some of that stuff tomorrow.
Cool.
We've got, I'll be on C# Fritz's channel on Twitch on Friday, and we're going to look at some of the NuGet packages that we talked about today. So we talked a little bit about like awesome Blazor and looked at some of the list of things there. We're going to do the same thing in depth on Friday. So we're going to dig in for about 2 hours and try some of those things out, kick the tires on a couple of them, maybe highlight some of our favorites and things like that. So we've got a lot more content planned this week. You can catch that at tinyurl.com, blazing-summer, or just follow the channel here at Code It Live, and follow C# Fritz's channel as well for Friday. And yes, those will start at the same time, 11 o'clock Eastern Standard Time for those. And it looks like we're going to be giving away some prizes here as we close out the show. So we're going to have some prizes coming up here. Not sure with what the team is going to do as far as picking numbers. They like to ask our hosts and me as well to pick numbers. Oops, I got the wrong slides up here. Trying to get to some closing notes here. Ignore the man behind the curtain. Here we go. So some more resources for you all. Telerik UI for Blazor is in full release. You can grab that at telerik.com/Blazor UI. We've got a brand new demo app up there called Blazing Coffee, which is really cool. Something I've been working hard on for the last couple weeks. We've got CRUD operations and server-side sorting, paging, filtering operations. There is, it's a PWA app, has some really cool theming capabilities that you probably haven't seen in any Blazor apps yet. So make sure you check that out. Links are up on the screen here. Fiddler is also a great companion. It's free. It's absolutely free download from us. That helps you build any .NET app that's got a API backend on it, which is pretty much everything these days. So you can inspect your HTTP traffic and all that good stuff. And we've got some links to some more docs.microsoft.com stuff in here as well. So make sure you take a quick screenshot of that slide. And then later today at 1 o'clock on this channel, we've got TJ Vantel coming on to talk about state management with React. And you may think that doesn't pertain to Blazor, but actually a lot of this, the patterns of that type of thing translate over to Blazor as well. So you might want to just check that out to poach some ideas.
We may have been heavily inspired by React in a lot of ways in Blazor.
Yeah, there's some great libraries out there as well in the .NET ecosystem that mimic these state management libraries from React too. So you can pick up some tips there with TJ at 1 o'clock. And 2:30, Alyssa's, 2:30 today. Alyssa's going to talk about some web design stuff. So make sure you keep tuned to the channel the rest of the day here at Code It Live. And with that, let's check on the prize situation. So let's see what we have going on for prizes. Dan, if you can pick 4 numbers between 1 and 126. For a random number. We're using the Daniel Roth random number as a service for our prizes today.
I assume they need to be integers, by the way, just to make sure.
Yeah, these should be whole numbers.
Should be whole numbers. Whole numbers. Okay. We're gonna go with 3, 17, because I think that's the number of Blazor WebAssembly previews we shipped before we actually got to the final release. 111. And I can't decide. 126. 126, the last one. Or does it have to be between it? Do I have to go one lower? Is that an off by 1 error?
No, I think 126 should be valid.
Okay. Didn't want to overflow the buffer.
So if you all didn't catch the show yesterday, we should have it up on YouTube soon. Maybe the team here, Sarah, if somebody can comment if we've got that YouTube video up yet. We talked about full stack.NET yesterday. It was really a fun session to give. We have Blazor WebAssembly on the front end. I've got the app up now that we talked about. So if you want to see more details about this app, check out the session from yesterday. We have Blazor WebAssembly on the front end, .NET Web API on the back end. and full authentication involved here, PWA app as well. And we have a demo on a nice dashboard like this where you can do server-side paging and sorting and filtering. So what we do is we package up all of the grid's state data and we ship that off to the Web API backend. And then there is a one-line piece of magic that our engineers made that converts all of the grid state into an entity framework set of expression trees. And it just takes that and turns it into SQL code. And you get only the page of data that you need based on that filter criteria back. So you're saving a lot of data processing on the server side, and then you're only shipping a small payload across the wire and only rendering what you need in the browser. So there's some really cool efficiencies there. And then we also have a demo in our data grid on how to do create, read, update, delete operations within Blazor and within the data grid itself. And one of the really cool things that's in here, it's kind of a little hidden gem, is you can click edit on one of these items. And in the nutrition information, you'll see a Telerik file upload button. So you can click select files, you can grab a docx file, so an Office document, and upload that to the server. Our Telerik libraries also include a document processing library. So when that file gets uploaded, the Web API accepts the file and then runs it through our document processing libraries and actually converts that into a PDF on the fly and saves it to disk as a PDF. So now if I reopen the grid that's refreshed, we have the PDF right there in the browser from the converted docx file. So this app, Dan, when I wrote this, it spent the last couple of weeks putting it together. One of the easiest apps that I've written in a long time because I was able to use .NET full stack. It's one of those things where when I write the code, it just works and it works as expected. So I think that a lot of the credit goes to the fact that the framework just is so intuitive to use.
It's nice to be able to just do one language, one framework, and just reuse those skills. Like you get that sort of accruing value for everything you know, which just pays forward in your front-end development.
There's one more little hidden gem in here too. This is not Blazor related, Dan, but this is a real fun one. So we have really extensive theming capabilities. So themes are really easy to use in our components and integrate those with any Blazor app. So if I go into my system theme settings, so I'm going to go into my OS theme settings. And I'm going to choose my color scheme. And Windows 10 has a dark and light color scheme now. I'm going to switch over to the light color scheme real quick. And my app actually just responds immediately to that new color scheme. So there's a set of media queries that you can put on your CSS files now that check the OS preferred theme setting. And you can just sniff that media query, and if your preferred theme is dark, you can load a completely separate CSS theme into your application.
That's cool. It just does it for you.
It's like magic. I love it. And it requires zero code. There's actually no code required to run that. So there's actually just a media query that you attach. If I do inspect here, and we need to get out of the tablet mode here. Let's do inspect again. I think it's hiding here at the bottom of the screen. There we go. If I go up into the head part of my app, you'll see there's two CSS files in here, and one has a media property, or actually both have a media property, but one has a media property that says prefers color scheme light or no preference, and the other one is prefers color scheme dark. And there's literally not a single line of JavaScript or C# code running that. It's a browser feature. And since we're using web standard tech, it just does what it's supposed to do.
Very nice.
All right, nice. Dan. Daniel, thank you very much again for joining us today. I think we've giving away our prizes. Do you have any parting thoughts or comments or things that you'd like to share?
Well, just thank you everyone for attending today. I hope you found it useful, and I hope you enjoy building your next web app with Blazor.
Awesome. Thanks so much, Dan. Just going to check with my team one more time. Sarah, are we good to go? Just make sure we got the thumbs up to sign off. Make sure they don't have any more prizes to give away or housekeeping to do. All right, so I don't see anything coming over. So thanks again, and thanks to Steve Sanderson for coming into chat, and I saw John Galloway in there as well. So definitely appreciate the Microsoft folks for showing up, and then thank you for the hundreds of viewers that showed up today too. Without you guys, there'd be no show. So thanks again, and take care, everybody. We'll see you tomorrow with Chris Santee, same time, same place. And have a good day.
Bye, everyone.